In this example, we see return loss failed with a margin of minus 6.4 dB. That's quite a significant failure. Let's go and tap on the screen here. When we look at the result here, indeed we see the return loss trace is below the red limit line, indicating yes, it is a failure. Now, from a previous video, I said there was a general rule that if it failed at, say, the lower frequencies below about 50 megahertz, then you could assume that there was a cable issue. But you've also got to check for a DC contact resistance issue. So let's go and look at resistance. When we look at the resistance, or 4 pairs, they are slightly different between each because that's the difference in the twist rates in the cable. But they're not significantly different. If they were more than 1.5 ohms or 2 ohms difference between them, then I would be concerned about a DC contact resistance issue. That's not the case here. Going back to our return loss trace, pinch and zoom in a little bit. You'll notice with this particular trace that all 4 pairs are pretty much following each other. As a general rule, when you see all 4 pairs following each other and they're failing, particularly at the lower frequencies, that suggests there's water in the cable. Now, okay, so there's water in the cable. Can we really clever and figure out where in the cable that water is? And with this instrument, the answer is yes. And this is how we do it. We're going to go to our diagnostic, our high definition time domain reflectometer. And I'm going to go to my shortest pair because that's going to give me the most accurate distance to where the water is, which is 4.5. Let me see if I can just pinch and zoom in a little bit here. What you're seeing here is a very significant impedance anomaly. Now, generally speaking, when you have water in the cable, where it starts, you're going to see an impedance anomaly of around about minus 10 to minus 15%. If you remember from my previous videos, generally in the cable, we don't want to see more than 0.8% or minus 0.8%, and clearly here we're seeing more than that. Now, if I mark it and bring it across like this, I say to about there, maybe a little bit more than that. I was probably there. What this is telling me is with this significant impedance anomaly going on here is in the last 3 meters, about 9.5, 10 feet, I have a water in the cable. And so we have confirmation there is water in the cable, the return loss failed, and it's located at the far end. Let me just also move this to where that first peak was, and you'll see the value of minus 9.3. Like I said, when there's water in the cable, it's not going to be a 0.8 or a 1.2. It's going to be pretty significant, and significant is minus 9.3. That's how you diagnose water in the cable.